Hello student, to the foundation of classical electrodynamics course. So, we are now still doing the module 1 with the mathematical preliminaries. So, today we will going to understand more about the line, surface and volume element in different coordinate system. So, last day we did it for Cartesian coordinate system. Now, apart from Cartesian coordinate system, how line, surface and volume elements are there for cylindrical and spherical coordinate system, how it defined, that we are going to understand today. Okay, so today this is class number 6. Okay, so we already defined the line element in Cartesian coordinate system, line, volume and surface element in Cartesian coordinate system. So, now we will do that first for cylindrical coordinate system, how we define it. So, my system is now in cylindrical coordinate system. First we need to draw the coordinate system itself. And then just draw 2 line here. And then I can join this line from here to here. What I am doing is I am making a volume element here first. So, this shaded one is the, I believe you can understand that this is the volume element I am just drawing first, which I can cut from this cylindrical system. So, this is a volume element that I just cut it from here. So, now this is my say x, y and z. Now, I define this coordinates here. So, this is my phi. If this is phi, from here to here, this is my d phi. Okay. And this from here to here, this is my d rho, and this slight increment is dz. Okay. So, what value, what is this value? This from here to here, since I am having this arc and this is rho. So, it is simply rho d phi. Okay. So, I almost define all the length, all the sides all the length and everything. So now I am in a position to simply write down what is the length element, what is the volume element, and what is the surface element. Once you draw this, then things are very easy and straightforward. So my drawing is not that professional because I am drawing this using my hand. In the books you will going to find a better drawing, but I believe you can understand that what I am trying to do here. Well, the length element simply dl should be the different length component that we are calculating. So d rho, so what are the lengths here? So d rho along rho unit direction plus rho d phi along phi unit plus dz along z unit vector. So this is simply the length element, and in order to find, you need to find first the volume and then the different elements of these volumes, different side length of this volume will give you this value. Okay. After having the length element, then we need to find out the surface element. What is surface element here? So I need to, there are three surface you can see. So these three surface if I draw separately, so one surface like this, another surface is like this, and another surface is like this. So the three surface I draw, whatever the chunk I have here. So this is one surface, this is one surface, this is another surface, and this is another surface. These three surface I am talking about. So here along this is my z direction. So z unit vector should be this. What is this value? This is d rho, and what is this? Rho d phi. What about this one? This one is rho d phi, and along this we have rho unit vector, and this length is my dz. What about this one? This is, so this is d rho and this is dz, and along this direction it is the phi unit vector. Okay. So for these three surfaces I know these lengths, so I can find out what is my the surface elements. So ds surface elements here is rho d rho d phi with z unit vector. In this case it is rho dz d phi along rho unit vector, and in this case it is simply d rho dz along phi unit vector. So these are the three surface element one can have here. One is this, another is this, and another is this, in three different directions. Mind it, you need to check the dimensionality. Rho d rho, this is the surface should be length square. In all cases you will find that this length square dimension is valid. So please check it. Well, what should be the volume element? Because I already have the volume element, so it should not take much time to understand that. The volume element dV is simply the multiplication of all these things, rho, then d rho, then d phi and dz, because all these three elements I know, d rho, dz, rho, d phi. If we multiply all together, then what we are getting is the volume element. So, this is the volume element for cylindrical system. So, for cylindrical system we managed to find out what is the volume element, what is the length element and what is the surface element. The main thing is that you need to draw this properly. Once you draw, then you will readily understand that how these volume elements are calculated. The next thing that we will do is to find out the same thing, the surface length and volume element, but this is for spherical coordinate system. Spherical coordinate system. For spherical coordinate system, we need to figure out all these three, and again the drawing is important. Again the drawing is important. Once you draw properly, then you can. So, let us try to draw this here, how one can find the volume element in spherical system. Suppose this is x, y and z. Okay, for spherical system, these are the spherical surfaces. I am cutting that. Okay. They are placing over that, and now I am going to draw this. This I am making a cut on that, and then I should draw from here to here. So, I am eventually having, so let us erase this part. Let us erase this part. So, I have a volume like this. So, this is the volume element I am talking about here. And here, this is a three-dimensional figure, so it is difficult to draw by hand, but I believe you understand that this is a volume and I cut a piece from that. I am just cutting a piece from that, that is all. Okay. Now, it is time to define this. So, this is my again phi, and this is d phi. This is r, so this portion is dr, and this is dr. So, this portion is these things is r d phi, and r d phi is this region, and r d theta. So, okay. So another, so r d phi, not r d phi, this is r d phi, and then one should have a sine component as well, sine theta, because I am having a theta here. R is this one, but I am having a theta here also, theta, and this tiny thing is d theta. So this quantity, this length should be r d theta. This should be r d theta. Okay, so all the length elements in now in my hand. So once we have this, it is easy. So first let us find out what is dl, the length element. The length element dl will be simply, because these three components are known, so I can have dr along r unit vector plus I can have r d theta, then it should be theta unit vector, and plus r sin theta. This is the projection of r over this. So this is the length I am talking about. This length should be r sin theta and d phi with phi unit vector. So this is the length element we got here. This is the length element we got. Now what should be the volume and surface element, that we are going to find out. So what should be the surface element? Like before, the surface element, I need to draw the surface again. So one surface should look like this, and this is r unit vector, and these things is r d theta, and these things is r sin theta d phi. Another surface one can consider like the side one, and along this direction this is the phi unit vector. So this length is dr and this one is r d theta. And another surface, again one can, there should be three surfaces, the bottom one, and in the lower side the theta unit vector goes. This is, this is, one is dr, dr is this one, sorry, and this one, this is dr, and this one is r sin theta d phi. So now you can calculate the volume surface element. So ds here, ds should be r square sin theta, r square sin theta d theta d phi with unit vector r. In this case ds will be r dr d theta with phi unit vector, and this case ds will be r sin theta dr d phi. Okay, these are the three surface element one can have from this segments. Now volume element is straightforward. So, volume element is dV, then I have all the line element here, all the line element along different directions. I just multiply all together, like we have in Cartesian coordinate system. Volume is dx, dy, dz. Here I have dx in place of dx. I am having dr in place of dy. I have r d theta in place of dz. I have r sin theta d phi. So I just simply multiply all these things. If I do, then simply I get sine square r square sin theta d theta d phi dr. That should be the volume element. Very important term, because we are going to use this volume element in several cases. Now the thing is, this is some sort of homework I like to give, and this homework is, please find out what is the total volume, because you know the volume element here for Cartesian coordinate system, for spherical coordinate system, and for cylindrical coordinate system. For example, for spherical coordinate system, you know the volume element. Now if I want to find out the total volume, then the total volume V will be the integration of dV, right? And this integral, so this E1 is known. So I know what is the values. So it is dr squared dr, and then integration of sin theta d theta, and then integration of d phi. Now if I want to find out the total volume for a sphere, I know the limit also. In sphere should have some radius, so the integration should be from, say, here 0 to the radius a, if it is a radius of a. Theta, I know what is the range of this theta, right? It is 0 to pi, and I know what is the range of phi, it is 0 to 2 pi. So if you calculate that, you will get some value. So please try to find out what value you are getting. It should be the usual 4 by 3 pi r cube, and you should get it from this expression itself. Okay, so now we will going to jump a more important thing after having this preliminary ideas about the volume element, surface element, all these things, different coordinate system. Now we will go to more serious things like line, surface, and volume integral. So this is really important here in this course. So let us start that. So we are starting in a completely new topic here, which is the line, surface, and volume integral. Volume integration, how to make a line integration, surface integration, and volume integration. So let us introduce this today, and maybe in the next class we will discuss in detail. Okay, so line integral. So let us start with line integral. What is the meaning of that? So the line integral, normally we define like a vector field. So okay, so normally I write like a dot dl. So I am having a line element here, suppose going from a to b, a line, and having a line element here which is dl, say dl, and also I am having a vector field here A. So, what I am calculating is these things over the given line. Say I am calculating the entire over the entire line this quantity A dot dl. So, eventually is the integral of the tangential component A along the curve L. So, if this is a curve say L, over L I am integrating. So, this quantity which we call the line integral is the integral of, eventually it is the integral of the tangential component, because eventually we are making a dot product here, mind it. So, the tangential component of A vector along the curve L. So, I am having a curve, this is my initial and final point, and I am making a line integral, and line integral is defined like A dot dl. So, what we are doing, we are just integral this. So, this is a vector, and if what is the component along this, I am just calculating each at each point and then I integrate, that is the thing. Interesting observation is the line can also be closed, right. I can start from here and I come back to this point. So, line, so here I am starting from A and I can come back to the same point B, A where A and B are the same points. Okay. Suppose this is the path I am following. So, then I have a special notation, I have a closed line, this is the notation normally we use, and this is saying that it is A dot dl I am calculating, but I am calculating for a closed loop, because the initial point A and final point B are same. This is a special implication is there, we will going to discuss that, and this is for closed loop, this is called closed loop. Okay. Now, what are the examples? The examples are very well known. For example, work done. When you calculate the work done by a force, W is the total work done, and how we calculate? We calculate like F dot dl. So, what we are calculating is calculating the line integral from one point to. So, now mathematically the force in Cartesian coordinate system, if I expand this, so force is Fx with unit vector I, Fy unit vector j, and Fz the unit vector k. And dl, this is the line element again, and we know that how to define the line element in Cartesian coordinate system. This is dxi plus dyj plus dzk. Okay. So, how you calculate f dot dl? It is a dot product. So, eventually I am going to have like Fx dx plus Fy dy plus Fz dz. Now, if I want to calculate the line integral, say I want to calculate this line integral from one point to another point, and this is f dot dl. So, this simply tells us that okay, I can calculate x1 to x2 if these 2 points like that. So, this is one point and this is point 2. The coordinate here is x1, y1, z1, and this is x2, y2, z2. Then the integration should be executed in this way, dx. I just do that. Then I should write y1 to y2 fy dy plus z1 to z3 fz dz. So, this is the way we calculate the line integral. So, next, I mean today I supposed to do a problem, but this problem is relatively a big problem. So, that is why maybe I will not going to finish this problem in today's time. So, next day we will start from this work done, not work done, rather this line integral concept, that what is line integral and how to execute that for a physical problem. For example, I mean you can do that, I am just giving you one example here, whatever the time left, but I can do a more rigorous problem. Suppose I am having a coordinate system 2 dimension, let us make life simple, x and y, and I am giving a path here. Suppose the path is from here to here and then goes here and then come back. So, my path is, if this is 0 or O, this is A, B. So, I am going in one case, I am going in this path from O to A and then B. So, this is my final point and this is my initial point. So, this is my initial point and this is my final point. But I am going to in 2 different paths. One is going from here to here and another is going to here, going this point from here to here, and a vector field is given. Suppose this A vector field is given, simply say xi plus yj. Now, the question is what should be the value. So, simple, I am giving you this as a homework, that please find out A dot dl integrating initial point to final point, and the path is, I should also mention the path because there are 2 different paths I already. So, path 1, this is for path 1, and you need to go from say O to A and then B, this is one path. Then again execute the same thing, initial point to final point A dot dl, and now I am giving another path, say path 2, which is directly from O to B. Okay. So, this is one problem, this is one problem, and this is another problem, but execution will be same. So, how you do that, I am giving you the hint, I am not going to do the entire problem, I am just giving you the hint. So, A dl, here you need to first execute what is A dl. A dl is A dot dl, which is a 2 dimensional problem. So, it is simply x dx plus y dy, that is all, right. So, when you have x dx plus y dy, then you should put it and then one by one you execute. For example, here the path, okay, I need to give the value also, otherwise I will not going to. So, this is say from here to here, this is this point, the coordinate of this point is 1 0 and coordinate of this point is 1 1. Okay. So, this length is 1 and this length is 1. So, when you execute for path 1, you can see that when you go from O to A, there is no change in y, only change in x. So, the dy term will not be there and you just need to execute this integration x dx over this length and your limit should be 0 to 1. When you go from here to here, on the other hand, your x will not going to change, your y is changing. So, eventually you get the value. So, let me do that quickly, it will not going to take much time. So, integration for path A, path 1, A dot dl is essentially, if I now start putting, for this length I have 0 to 1 x dx, dy will not be there 0, and for other case it will be 0 to 1 y dy, and this value is x square divided by 2 with the limit 0 to 1 for the path. This is the path for OA, and this is the path for AB. Okay, and then for other case it should be y square divided by 2 and 0 to 1. So, whatever the value is there, you can find out. It seems to be you will get the value 1, that should be the case. I am just giving this arbitrary problem, but the procedure you need to think carefully, that when you go this path A dot dl, you need to execute, and you first find out what is A dot dl. You know that line element, we just learned that A is a given vector. So, you just find out what is A dot dl. For example, here it is x dx plus y dy, because my vector is like that, x I plus y j, and then you will get the next another trick of this problem is how to find from O to B, because this path is fine, because here in one case the x is not changing, in other case y is not changing, but in this case x and y both are changing. So, in this case the trick is, you can see the coordinate is 1 1, that means the change of x and y is same. So, x equal to y. So, in the entire equation if you put x equal to y, then your integration, for example, dy you just replace, it is x is y here, because it is changing like that. So, it should be, the integral should be just 2x dx, and then you integrate, and change of x, the value of the change of x is 0 to 1. So, you just integrate and you will going to get the result, that is all. So, in the next class maybe we will going to discuss in detail about a more critical problem, and we will execute that, how to calculate the line integral, and also in the class we calculate the surface integral for a given problem and the volume integral. So, with that note I would like to conclude. Thank you for your attention, and see you in the next class.